Another session today to be the continuation of the last week's session. We'll be talking about scaling prototypes into ML models. It's a continuation of. Hello, can you hear me, Mr. Buffet?
Hey, good morning. Yes, I can.
All
Please
all
continue.
right, please go ahead while other students join, and if not, we'll be sharing a recording of the session with them. Thank you so much.
All right, so I can begin.
Oh, yes, please.
All right. All right, thank you. Thank you. Good morning, everybody. Oh, good morning, Beatrice. I hope I got it right. Yeah. Thank you for joining us today. I hope so far this class has been informative, and I hope we have learned a lot.
Yes, sir.
Last
Good
class,
morning.
sorry.
I say yes, it is, and good morning to you too, sir.
Thank you. So I will continue. In the last class, we talked about scaling models and understanding what a production environment is and the difference between a production environment and training environment and how it takes a lot of work to get machine learning models to the production side of things where we can get them to face real world data and real information. So what I'm doing now is a very short recap before we move on into what we will do today. All right. So we also briefly talked about serving and scaling, where serving is putting the model online and where scaling is making sure the model can handle the workload we are exposing it to. All right, so we talked about the two different things, and we talked about the different types of scaling, where you can scale vertically or horizontally, and how one is limited and the other allows you to grow exponentially, right? So today, what we're now going to focus on is I mentioned we'll have a practical class, so we're going to stick to that, and we are going to, well, I intended to work each and every one of us through each step in this class, so I'm still going to do that. I'm going to share a folder containing two files, and those two files we use throughout this course, right, throughout the class today. All right. So today what we'll be doing is we're going to train two machine learning models, right, on the same, no, on two different data sets, right? And then we're going to see how we're going to compare the metrics for model A and model B, right? We're going to see if basically we're going to do some feature engineering and we're going to try to make the original data better, right? Get it to another level, which is what feature engineering is. And when we do that, we're going to train model B with the feature engineered data set. And then we'll compare the metrics and we'll see did our feature engineering and did it help the data, the model learn better? Is our model going to perform better because of the data modifications that we did, right? And then the trainings, because we're going to do two different types of trainings for the two different models. And yeah, so we'll see if our efforts will make a difference in the way the models work. So we'll train two models and we'll see what they're talking about, basically. All right, so before I go on, I'm going to walk us through a couple slides, very few, and then we'll just understand what we're trying to do today, and then we'll go straight into the practical. And like I said, we'll work through each step by step. Jessica, thank you for joining us. Good morning.
Good morning, sir. Thank you.
So I'm about to share my screen, and then we'll go into the content for today. And because you just joined, I was saying we're going to do some practical classes, but we're going to have a brief introduction before we get there. All right. Kindly confirm that we can see my screen, and then I shall begin.
Yes, we can see your screen. Please go ahead.
All right. Thank you. So like I said, today we'll be building a customer purchase prediction model with BigQuery ML, right? So we're going to use one service from Google Cloud Platform, and we're going to build two models with it, right? And the purpose of the model that we're building is to determine whether a customer, based on historic data, will determine if the customer will buy one of our products or not, right? So we'll have different information. We'll see that in our data set. And then we'll train our model with the data, and then we'll see if our model can predict whether the customer will buy our product or not, right? So it's a binary classification, either ones or zeros, where one means yes and zero means no, okay? So what we achieved today is we're going to do some feature engineering. We're going to create some different new feature. So basically a feature is a column. And if we're doing feature engineering, we're creating a new column so our model can learn better. So we're going to do some feature engineering, and then we're going to train our models, right? So we're going to train two models. We're going to train one model. So we're going to train model A with the default setting. So we're not going to change anything. We're just going to write the SQL code. I'm going to train that model, and then we'll evaluate the metrics. We'll see how the model performed and that, right? And then we'll train model B using, a little more extra effort, right? So we'll fine tune a couple things, and that will bring me to hyperparameter tuning. So we'll fine tune the hyperparameters for the training session, right? So like I said, model A, we're going to use the default training settings. And for model B, we're going to do some hyperparameter tuning and feature engineering, right? So hyperparameter tuning is basically you're training you're you're cooking a pot of food, right? And you already have your ingredients in it. I find food analogies a lot easier to explain, so I'll stick with that for the most part. So we're cooking a pot of stew, right? But we already have our ingredients in it, right? The fire that keeps the food hot or keeps it cooking, right, is what you call an external settings, right? It's not in the pot, but it affects what comes out of the pot. Because if you cook it for too long, it could burn. If the fire is too high, it could burn. If you leave it it could dry up or it might become soggy. So many things go wrong if you don't monitor your file, right? So that's what hyperparameters is. It's the settings, the training settings that surround that model training session, right? So we try to find the best hyperparameters to give us the best model with the best, that brings the best prediction outcomes, right? And then we'll evaluate our models. And I think I'm going to leave the prediction part of it to us as an assessment in a sense. So after we evaluate our different models, I would like us to, do some assessments by making predictions. So I'll show us how to do it, and it's already in the files that I will send. So what type of model are we creating today? So we're going to do a binary classification with logistics regression, right? So basically what that means is binary classification is classifying a particular value or one or two values into their classes in a sense, right? 1 second. Um, my bad. I needed to attend to something. So like I was saying, we're going to build a binary classification model. And basically, when you say classification, you're trying to classify if an observation, for instance, falls into category A or category B, right? And for our use case, we're trying to see if this customer is either going to make a purchase or is not, right? So there are two categories for us, and that's, well, a yes and a no, right? So binary classification is usually used to separate an observation into its accurate class in a sense based on the predictions, right? So our customer data is going to provide us with the columns and information we need to train our models. And it contains the ID column, and I'll show us this, an age, a gender, an estimated salary, and purchase column, right? So we're going to see if uh, client client A, based on the salary and the age and the gender, will buy a product from us or not, right? So we're going to that's just an idea of what it means to look into your data and try to get information from it. So that's briefly what our data is about. And like I said, our prediction target would be, will the customer make a purchase or not? So it's true or false, one or zero, yes or no. And then in logistics regression, output probabilities for binary classification tasks, right? We'll see more in this as we go on. All right, so the key concepts for machine learning are features. And like I said, our features are our columns, right? And basically like our ID column, our age column, gender, those are what features are. They are the information in our data, right? And then the labels are the targets, the column that we want to predict. So if we have 6 columns, 5 columns, we could have 4 features and 1 label, right? So 4 columns explaining the output for 1 column, right? So that's a ratio 4 to 1. So our target is our column that we want to predict. And then feature engineering, like I said, we're creating new columns, new features, right? We're creating new features using some engineering, some basic machine learning formulas. And then we're hoping that by creating these new columns or features, our model can predict this label better. And then training basically is the process in which our model learns its weights and biases. Don't worry, they are just parameters like our stew, our tomato and onions. So we are determining the right amount of tomatoes and onions and seasoning, right? That will make our stew come out as perfect as we want, right? So the training is just the process in which the model learns patterns from our data. So it learns, okay, customer A is a male with this salary and this age, and he made a purchase. So if I see another customer in that same area, who probably make a purchase, right? And so same goes for females and so on. So the training is where the model learns patterns from our data. And then hyperparameters and versus parameters. So like I said, the parameters are our weights and biases, our onions and our garlic, and all those ingredients that go into the pot, right? So they are what our model learns. Our model automatically learns during training. So the model discovers these values from our data, right? And I won't go too deep into that, but I just want you to know that weights and biases are very important parameters when it comes to machine learning, because that's what our model learns to balance its predictions or to make its predictions. And then, like I said, hyperparameters. Now, hyperparameters are more like external factors that help our training process go well. So there are settings that we adjust to make sure our model learns the parameters well, right? So we have an L1, which is a least absolute shrinkage operator, right? And it's just a hyperparameter that pushes our unimportant weights to 0 for feature selection. And what that means is if we're using the L1 hyperparameter, right, feature, right? If we're using that in our code, it's going to affect the weights or the features so our features determine what weights and biases our model learns, right? Our feature is our input data. So our model learns from those features, the combination of the features, and then determines if our customer will buy our product or not, right? So what this hyperparameter tuning does is we have 4 columns, but it will determine that, okay, in a sense, it can push, let's say, our gender and the ID column. We can push all those values to 0, right? Because it has determined that they're not going to affect our label, which is our prediction. They're not going to influence it in a way that makes sense. So it's best to just leave them out, right? And that's what the least absolute shrinkage is. It just reduces the unimportant weights to 0, right? So this weight, it reduces them to 0 because they're not important, right? And then the L2, which is our ridge, it shrinks the weights to reduce overfitting. Overfitting in machine learning basically is when your model is overlearning parameters. It's learning from things it should not be learning from. So that's overfitting, right? And you don't want that because it's going to make wrong predictions. So you use L2 to shrink those weights that are irrelevant to our learning curve. So based on our use case, we don't care about their ID or their age in a sense. We just want to know that if you have the money or not, right? So, okay, we don't care about their ID or their gender. All we want to know is, okay, this certain age, he has a salary. Of course, he can buy our product, that type of thing, right? So L1 and L2 just try to reduce the unimportant weights as much as possible. And then our learning rates is also a hyperparameter that we use we determine how fast our model learns. If it learns too fast, the training is unstable. If it learns too slow, there's a slow convergence, right? It just takes too long, and then if it's taking too long, it's learning unnecessary information. And if it's too high, it's too rapid, it's missing important things. So usually we keep our learning rate at about 0.1. And then if we need to speed things up gradually, we speed things up. And then max iteration, basically, it means how many times we want to perform this training. So we could have, and we'll see that in the training, we can have 10, we can perform a particular training as many times as we want, really, as many iterations as we want, but it's just running the same training code over and over and over and over again to see which hyperparameter gives us the best learning, right? So we'll try and determine what hyperparameters, the combination of these parameters, this, our learning rate, our this, what will give us the best weights and biases that will give us the best predictions, right? So I know that sounds confusing, but we'll see. We'll see that in the practical. And so hyperparameter tuning, like I said. So this is an automated model optimization, right? With a few lines of code, we can make sure that our model learns better, and we can make sure that the training session is as efficient as possible. And then we will train out that model as many trials as possible to get the best performing combination that give us the best performing predictions, right? So we'll see that in the class. I won't dwell too much here. And then the goal is to make sure that our model is better than the default settings. So like I said, we're training two models, A and B. We're going to train A with the default settings, and then we're going to train B with some, effort, some hyperparameter tunings and some feature engineering. I want to see if by affecting this training settings and giving it better information, will the model make better predictions? So and then the key evaluation metrics. Now we'll see more, but this is just a brief on what metrics that we'll be looking at, right? So we have the accuracy, precision, recall, and the F1 score. Now, accuracy basically determines how accurate our model is. So it's the overall percentage of correct predictions, okay? And then the precision is how correct our model was. Now, I'll just say this before I go further. A lot of these individual metrics, they are related, right? So recall and precision are related. Your accuracy is affected by the precision, right? And your F1 score is the balance of your precision and your recall. So throughout the evaluation part of our practical, we'll be looking at all the different metrics that are monitored during the training process. And then we'll also look at the evaluation metrics, and we'll really just understand those metrics and understand what they mean for our model and how their interconnection, how getting a good balance on all those different elements make our model perform better or help us, the engineers, decide what our next best move should be. Like, do we need to feed it more data? Do we need to remove some data? Do we need to fine tune some more hyperparameters? The different things are just, we're basically cooking and we're cooking from scratch, right? With only our data in our hand and some utensils and some skill sets, some knowledge. And we're going to try to make sure our model, what we're trying to make, our stew is the best ever, the best stew out there. So that once it's, good enough, we can move it into our restaurant and start selling, right? So that's what it is. We're going to look at the different metrics, our accuracy, precision, recall, the F1 score. We'll also look at the advanced evaluation metrics like the ROC, which is our receiver operating characteristic curve, right? It just determines how well our model performed, right? How well the classification occurred. So it's a curve that checks how well the binary classification works, right? So how well did our model separate the positives, the true positives from the true negatives, right? And we'll look at those terms later on. And to make things even better, I'll share us a document that'll help us explain this metrics so you really understand how important evaluation is to your machine learning lifecycle, right? So we'll look at the ROC curve, the area under the ROC curve. We'll look at our log loss, and then we'll look at our precision and recall curve, and also look at our precision and recall by threshold. I'll define some of those things. So our log loss, it measures the prediction confidence, right? So a lower value indicates better calibrated prediction. So the lower the loss, the better for us. So lower our log loss. And usually when you see loss, it's usually lower the loss, the better. And that's the whole thing with machine learning. We're always trying to reduce our loss as much as possible, right? So, and then we're trying to increase some other metrics to make sure that we find balance. So we'll look at this in our practical. And then this is our practical workflow. We're going to just train two basic models. We're going to evaluate our model, and then we'll do feature engineering and train another model, and then and then we'll train an improved model. So train a basic model, evaluate the metrics of that basic model using the basic default settings, right? And then we'll do some feature engineering and we'll train another model, and then we'll compare these two models together and see if our extra effort made a difference, which is what machine learning really is all about putting in effort. So the final steps, we're going to compare model 1 versus model 2's metrics. Like I said, I'm going to leave you to do the batch predictions. So we'll just do it on our existing data set and just see if our model is making correct predictions. And then we'll discuss this briefly. I'll see which one performs better. All right, so I'm going to stop sharing my slides now, and then I'm going to, all right, I'm going to stop sharing my slides, and I'm going to send the file, the zip file, to the chat group so we can download that. And I'm hoping that we're with our laptops because I want us to actually do this together. So I'm going to do this right now. I'm going to send the files. I'm going to do it together. I'm going to upload the documents. So I'm going to create our models. You'll see in the files that I sent more information, so I'll do that. Yeah. So yeah, I was going to say, I hope we have our Google Cloud accounts open. If not, I can walk you through open it, but it'll be good to open the account now and so we can have this work through together. Uh, Good morning, Patricia. Uh, you're welcome. All right, so if we will go ahead and check the chat room, I have sent the zip folder. So we just need to open it, download it, and get the two files in it. All right, good. So once we do that, I will proceed. Kindly let me know when we have all, all downloaded the folder so we can proceed. Thank you.
Hello, Mufe, are you there?
I'm here. I'm just waiting for,
Oh,
yeah, I'm just waiting till everyone has the folder and we can proceed. Or can I proceed now?
yes, I sent the folder to the group. Please, you can proceed.
All right. All right then. So I will share my screen and I'm going to do it from start to finish. So I hope you can follow along. And if there are any questions, just let me know. All right. So I'm going to start from the scratch. Like I said, we're going to go to Google Cloud. All right. And here, on top right corner, we have the console button. So we'll click that. Let me change the account. So we'll click go to the console. This is where we do the machine learning things. All right. So from our previous classes, I'm sure we know how to make projects. If not, this is how you go to create a new project. In your top left corner, you click here, and then you can create a new project. Fill in the information, and then just create. And once that's done, we'll have a new project. But I'm not going to do that because I already made one, but that's the straightforward thing. So after we have our project, once we click on it, so we click on project here, now we're working in that project. And like I said, we're going to focus on BigQuery ML today, and this is how you find BigQuery ML. Just right here, and there we are. So now that we have BigQuery ML, we are going to, first of all, get our data and the information that I gave us in the zip file, right? So we're going to create a data set. So this is our project right here. So let's create a new data set. Create a data set. I'm going to call it set, right? We're going to put our location in the US Central. Now, I mentioned using two before. So it's either you use this US Central, which has a lot of the features that we'll need, or the functionalities and the hardware that we need, or we use the North Europe West Netherlands one. Let me just show you. Yeah, so Europe West, not Netherlands, which is the closest data center to us. But if we're going to just focus on the US Central Low for the remainder of this course. So we'll use this and then we'll create our data set. So now we have our data set. Let's import our tables. So we're going to create a table, right? You could do it like that, or we do this. We click on our data, click on the data set, and then we see our tables, and then we click create table. So I'll do it like this. And then we'll upload our data set from our laptop. And you can see there are other ways to import your data, but we'll just do that from our laptop. And then we'll pick our files. So for this, we're going to use our customer trained data. Now, this is what you should have in the folder that I sent, a practical walkthrough. We're going to upload this file. And we're going to upload our customer data set. Now we're going to click on this, open, and then we're going to call it customer And let's use table, so it's more, so we know that it's a table. And then we say native table. Remember to always click auto detect on your schema so that it knows that your table has headings, right? So all the columns have headings. If not, you might run into an error. So we'll create our table. And now we have our customer train table right where we need it. So like I said, we need to upload our queries, the other file, which is a file that contains our walkthrough for this practical class. So we're going to click on queries. Right. And then we're going to upload an SQL query. Right. So we're going to browse and you can see it, practical walkthrough. Open that file. The location is the same, so make sure that our location is US Central all the time. So that is the, connectivity. So our data is stored in the same data location and region. Just makes it easier. Okay, so now we have two files, but you should have one. I just created the file using BigQuery, so that's why I have two. But you should have one, and this is what the file will look like. So it's basically going to contain our walkthrough for this class. And like I said, we're going to train our models using BigQuery. I'm going to do a default training, and then we're going to do a training with feature engineering and hyperparameters tuning. And then we'll compare the model's performance. We'll look at the evaluation metrics. Now, basically, what we're going to do is we're going to follow each step one after the other. And what I've done is I've added the code to each step. So all we need to do really is just copy this, right? Copy this, open a new query, the new query tab, and paste it, right? So the only thing we're going to be changing throughout, or what you're going to be changing throughout, is going to be the location that you're going to place your model in and the location of your data set, your trained data set. So those are the two things you most likely change. But like I have looked at the code, and if there's any problems, we'll just work through it together. Okay, so like I said, we're gonna do step one. So might as well just start, right? So today, this is our practical walkthrough, and we're going to start with step one. We're going to train model A, and this model is our baseline model. We're just going to use raw data set, no feature engineering. So let's look at our data set and then see what we're talking about. And I'm going to open this. All right. So this is our current clean data set. This is just what the columns we have, our features. So we have feature one, ID, feature two, gender, feature three, feature four, and then our label, which is our target, right? So this is what we're trying to predict, our purchase. So we're going to use these four columns to predict whether the customer purchased yes or no. So like I said, this is our basic data set. We're not going to do anything, no feature engineering. You can look at more information about it. This is our data location, the size of it. If we want to preview it, yeah, so let's look at what our data actually contains. So our rows, the ID, the female, so the gender, the age, and then estimated salaries, and then whether they purchased or not. So you can see this is false. This is false. This is false. Yeah, there's a lot of false. Yeah, we have a true female, so she's 27, and our salary is like 96K. So that's not bad. So let's try and see if we can predict when a new customer comes, are they going to buy our product or not, right? So now we've seen our data, seeing what it looks like. And I know Mr. Marvin, talked about and walked us through the different subpages, but let's move forward. Okay. So now that we see what our data looks like, let's try and run our first code. So we're going to copy this code right here, and then we're going to put it in our new query. And like I said, and if you remember, these are just SQL commands. So we're going to create or replace a model if it already exists. And now we're trying to specify where we want to put that new model we're about to create. So I want to put this model in this custom data set. So the data set, let me show you what it looks like. So our custom data set, right, has these sub pages. So it has our tables, graph, models, and routines. So we'll be working with our table sub page and the model sub page, right? So when we create a model in this data set, we'll see the model right here. And that's what we're about to do. So if we go back to our query, okay, let me close this up. So we go back to our query where we're going to try and create our model A. It says, this is our project. So I'm going to put this. Right, so this is our project. This is our project location, right? And then our data set is going to be customer. And this is going to be our data set, customer data set. Okay. Yeah, so always pay attention to your letters, the capitals and small letters, they all matter. And then when you see, note that when you have a dash in between your names and your projects, try to enclose them with an apostrophe or something, right? But just pay attention to this too. I'm going to copy this and put this on the file. Yeah. Basically, so now we know where our project, our customer data set, that's where we want to create our model in, and the name of our model. So this is model A, right? We also now look at, so we'll also now look at the type of model that we want. So this is a parameter. So the type of model that we want, our model type is a logistic regression. And then the inputs label column, which can also be known as our target column, right, is purchase. So this is a column we're trying to predict. And then we'll select from our data, our training data, the age, the estimated salary. You could even put gender in there. Let's put gender in there. So capital. So we'll put gender in there, right? So we're going to select our age, our 4 columns, age, estimated salary, gender, and purchased, right? From our data, our table. So our table is this one. So we're going to change the name. So this is our project ID. Like I said, forget what it's called right now, but it's like an apostrophe in a sense, right? So you put that, and then your location of your data set, which is our customer data set. So we'll do this. Customer data set, and then our data, our table. So it will be train table, right? So now we have, and this is all it takes to create a model in 2026. Thank God for technology. So we're gonna run this, and then we'll see our model actually train live, right? So there we go. Our model A is training. You can see how long it's taking right here. So once it's done, we'll look at more information. So while this is training, let's go and look at our walkthrough and see what we're going to do next. So now that we have a model 8 trained, right in the code, right, our expected result should be model A is created successfully. So our next step would be to evaluate the model. Like I said, this is done we trained this model with the default settings. So we didn't really change any parameters. We just gave the model, used some code, gave the model data, and began the training process. So like I said, we're going to evaluate the model. We're going to look at metrics like the accuracy, precision, the recall, the ROC curve, and the log loss, and some other metrics, and then we'll see how the model performs. We'll try to explain it. So let's see if it's done. See, there we go. So we have successfully created model A, model named model A, right? And if we go to our model, which is going to be, you can find that under the customer page right here, the customer data set page. So we see the model here. But if we click that button, it also takes us to the model, right? So let's just do this too. So you see, we have our model page right here. We have the details, the model type, logistic regression, the ID, model name, data was created, our location, which is important. And then they modified. We have some, so now you see, we talked about hyperparameter training, fine tuning, right? And you see these hyperparameters here, L1 and L2 regularization, which is basically what they do. They just regularize the weights and biases. They make the unimportant ones irrelevant to our training process and to our predictions on our outcomes, right? So L1 and L2 regularizations, you can see here, they are 0 because we didn't change anything. Okay. So the training options, we didn't change anything. The actual iterations that it modeled. So how many times the model was trained? It was 9 times. And the max allowed iterations was 20. So we gave it a gap for 20, but we only did 9 because that's the training process determined that 9 was enough, right? So we also look at, so basically this is an actual default training settings. The learning rate strategy, linear search, calculates p-values, false, data split method, auto. So all these are just basic default training methods, but we'll only be changing this. We'll change our L1, L2, our iterations, and the learning rate if we can. So I think what we're going to do now is we're going to look at it. We're going to look at the feature columns, age, estimated salary, gender, and then the predicted purchase. So this is our target. So we can see the difference, our label column, which is our target, and our input data, which is our feature columns. Let's look at the training metrics. Now we look at this graph, we can see the loss. Naturally, you always just want to see your loss go downwards, right? It just has to go down. So in machine learning, the lower the loss, the better. The goal is to just make sure our loss is going in a downward slope. And as you can see, the loss here is just going. So after the first training, the loss dropped again. So basically, as the more training your model goes, the lower the loss because your model is learning more patterns from the data, from the training data, right? So as you can see, after training 2, the loss dropped again. By training 4, it has dropped to 0.3, training 5, 0.2, and then at the last iteration of the training, our losses are 0.24, which is good. So our loss is dropping. It means our model is learning, right? And then this is how long each training session took, each iteration took. So this took 1.6 seconds, and the highest one was about 2.3 seconds. So this is actually very fast. And then you can look at the learning rate curve. So you can see that the learning rate increased with the number of iterations. So like I said, the learning rate is how long or how fast our model learns. If it learns too fast, it will be unstable. If it learns too slow, it'll be learning too much rubbish, right? So basically what the automated training does is, which is what big query ML does, it does it automated for us, so we don't have to manually write the code, right? So we see the learning rate grows. It goes up to this point where at iteration 6, our learning rate was at 12.8, which is actually pretty high. But you see, by the time it gets here, it drops, right? So it means that, and our best model, right, which is what I'll look for us, then this is the best version of our model, defined after the last iteration. This is our best version. And the learning rate at that point was 6.4. Okay, so we're saying our model learns the best or learned the best at a learning rate of 6.4 at the value of 6.4. So those are the training metrics. We looked at our training metrics, right? So we can see the iterations, our loss data, it goes from the first training session to the last, it goes from 0.6 to 0.2, right? And then the learning rate for that, which is at a very low loss, our learning rate was 6.4, which isn't the lowest, but it is the balance is what we're looking for. So basically, we're just trying to find at what values does our model make the best predictions. And it took it was the longest, and it was the longest, the longest training session. So we're seeing our data, we're seeing our training data, and we're trying to understand what our model is telling us, what the training happened, right? So now look at the evaluation. This is still model A, right? So look at the evaluation for model A. We have a threshold, precision, the recall, accuracy, F1 score, logit loss, or log loss, and then the ROC, the area under the ROC curve, right? So I'm going to explain this different metrics, and then we'll look at how they connect. We'll also look at these graphs below. So what is the threshold? Now, a threshold basically it just determines at what point do we classify our, so let's just use our customer data set to explain it. So let's say we have customer one, right? Customer one is false, customer two is positive, customer three is false. So we have two false and one positive, right? Now, a threshold means at what point do we classify the customer's information as positive or as negative? So do we say at a threshold of 0.6? So any customer that has a predicted value of 0.6, do we say that customer is going to buy from us or no? Do we classify the person as a yes or a no? Okay, so basically what a threshold is like a benchmark. If customer's predicted value is above this particular threshold, we'll classify it as yes. If it's below that particular threshold, we classify it as no, right? So we set our threshold to determine the best possible threshold for our training process, right? So I'll explain about it more, but let me just leave that as threshold, our benchmark, right? And what is the precision, right? The precision basically is, excuse me a second. I'm back. So we talked about threshold, the benchmark for when we classify an observation as either positive or negative, right? So we set that threshold. Then we look at precision, right? Precision basically just talks about how of the total number of values that our model learned from, or let's say we're trying to, so basically our binary classification is trying to determine, I'm trying to get it, as calmly as possible. So our binary classification, right, is trying to determine if we get a value is, or your observation is positive or negative, right? So when you say precision, you're trying to say, oh, okay, if our model says this observation is positive, is it correct or not? And that's where we'll look at true positive, and that's what we call a true positive. That if the value for an observation is true, that means yes, they got our product. And our model also predicts it as true. That's a true positive. So our model is getting that the value that it has determined is positive is actually positive. So that's what precision is. Is it actually getting it right? And then we talk about recall. Recall basically is just of the total number of positives in our data set. How much did our model get right? So how much did our model call? So let's say if we have in a data set of 100 rows, we have 70 correct values, so 70 positives. How many, and we train a model with that data, right? Now, our recall will say, out of the 70 positives, how many did our model actually find and identify as positives, right? Because you could have, so our model could pick a value. So it could make a prediction on an observation, and it could say that observation is false, right? But in actual fact, the observation is positive. So that's what you call a false positive. Our model has said it's positive, but it's not actually positive. And like I said, I will share that document and you actually see and understand what these terms all are about. And then we have our recall. So I was saying, did out of the 70 in the data set that are correct, how many did our model get? And in our data, in this training metric, our recall is at 0.2, which means that our model is actually getting it's very poor in the recall metrics. Because if out of the entire 70% that are true positive, our model is only getting 0.2%. So it's just getting about 2%. No, it's getting about 20%, my bad. So out of the entire 70%, which you will call 100%, our model is only getting 20% right. So it means our recall is poor, right? Then we look at accuracy, right? And accuracy is showing us that it's correct. So it's showing us that we're getting 80%. So that's what 0.8 is. Our model is 80% accurate. But I'm wondering as an engineer, how can our accuracy be so high, but our recall be so low, right? And our precision be low as well, right? Because higher precision would be a precision closer to 1. So precision closer to 100. Recall as well. But in machine learning, we rarely ever get them 100, 100. We just usually focus on the balance, the sweet points where our model is making the correct precision and we're getting the total number of accurate positives, right? So that's what I said. A combination of these metrics make up our accuracy and our F1 score. F1 score basically is the balance or the average of your precision and recall. And a higher F1 score is usually better. But for this one, we are getting 0.3, which is by by definition low, right? So our model isn't, I wouldn't say this is the best version of our model, right? Considering that we use default settings to train it. So we look at the log loss. And like I said, log loss, anytime the loss, loss is better just when it's going low, right? The lower the loss, the better. And then the ROC, so which is the receiver operating curve, basically just trying to show us the performance, how our model performed. And we'll explain, I'll explain these curves now, right? So if we look here, we have our precision recall curve, right? This is a curve that plots the precision and recall by threshold. And what I mean by that is, I said our threshold is the balance. It's the benchmark for when we can classify a model as, or a observation as positive or not, right? So a precision recall by threshold curve it tries to show us the sweet point. So at what point did our model get So before I go there, let me try and explain the relationship between these three values, right? It will be more better that way. So precision is, like I said, how correct our model is. Recall is out of the actual positives, how many did we actually identify? And then threshold is our benchmark, right? It determines what we classify, the point at which it is determine what we classify as the positive or negative observation, right? So what this graph helps us do, it helps us see the trade-off because the lower the threshold, the higher the recall, but the lower the precision, right? So if we lower our threshold to 3.5, and this is a threshold on the y-axis, right? So if it's going 0.3, right? So it's going from 0. from 0 to 1. And if you look at this point, this is our highest precision. This is where our precision is at our highest. And depending on your use case, some people might want you to, some business problems might need you to be very precise. You want your models to be getting precise values. So like fraud detection. And for our customer prediction, we want to know, is this customer going to buy or not? So that we're not just, okay. So we're trying to focus on precision, right? And while recall is, and some people might want to focus on recall. So like medical practitioners, they want you to just get all the information right, all the close positives. We don't really need precision like that, right? But for our use case, we want to focus on prediction, but we also want to make sure we have the right amount of recall. But the threshold really affects our recall and our precision in the sense that if we lower our threshold to about here, it means that our recall is about 100%. So we're getting all the information from our data, but we're getting the positive data, but we're also getting in some negative data, right? So we're getting some true positives, but also getting some false positives. So that means our model's predictions are going to be wrong, right? So that means the threshold is too low and it's allowing wrong values to come out, is allowing our model to learn from wrong values. Now, if we move further along the threshold, threshold confidence, so we move it to about here, which is, what is this? This would be around 0.5, right? Yeah, so 0.5. We can see that our precision has begun to increase. It was here before, so it means our model was very low in its precision, but it's gotten to this point, right? So it means our at a confident threshold of 0.5, our precision is relatively higher, but our recall is dropping because we're trying to make sure our model is as precise as possible, but it also means we're not getting in all the actual true positives in our data set. And the goal is to always try and find a sweet point. And this is where the sweet point, we could say the sweet point is. This is at the point where our precision is at 60, our recall is also at around 50, and our threshold is at 0.5. So now we've identified that at a confident threshold of 0.5, we're getting decent precision and decent recall, right? Because if at this point we can see that our precision is at 66, but the recall has dropped all the way to 7.9%. So which is very low. It means we're not getting enough positives in. Now we look at the precision recall graph. Sorry, the precision and recall curve. Now this curve just explains to us the area under the graph, and what it means is on the x-axis we have the precision and on the y-axis we have recall, right? And this is the area under our graph. So at this point where our precision is the highest at 66%, our recall is at 7%, right? And basically what this curve monitors is, yeah, so what this curve monitors is it monitors how well the model identifies the positives without being overwhelmed by the false positives. All right, so basically it's trying to see how well our model identified the correct positives without having to deal with a lot of negative values. And you'll see a lot of this information in the chats, but let's move along. And then the ROC curve is a curve that explains how well our binary classification worked. Now, the precision recall curve focuses on performance, and our ROC curve focuses on how well the binary classification worked, right? So how well did it identify the difference between the categories or the difference between the observations? All right, so we'll look at this, and then when we build model B, we can see and try to compare if our extra effort made a difference to the model training and predictions. Right, so we look at the coefficient matrix. So basically what this coefficient matrix is just explain to us It just shows us how the model classified or evaluated the observations. Now, if you look on the right left side, the true labels is what the actual label of that observation is. And if it's true, and then on this side, it looks at our predicted labels, this is how the predicted values, this is what our model predicted, right? So the true value and what this graph is showing us, or this matrix is showing us is that of all the true values present in our data set, our model predicted 100% correctly. And then of all the true values, our model predicted none as false. So we're getting 100% on correct. So, and for for the false labels of all the true, and when the observation was truly labeled as false, our model predicted it 100% correctly. So it means there's a lot of metrics, as you can see, a lot of different factors that make up that monitor that help us evaluate our models. And this is why not a lot of models get to production stage, right? A lot of models are just developed in prototype, and they never really get to predict production because, well, it takes a lot of time and effort to get a model to make completely accurate predictions on unknown data. So I'm just trying to show you how much depth it is. And if we look here, we can see this is just this allows us to play around with the thresholds and see how threshold affects the different parameters. So if I put our threshold on 0.3, you can see that we have our precision at 0.5 or 50%, recall at 50%. Our accuracy is high, and our F1 score is at 5, so this is okay, right? If we move it down, if we drop our threshold to about 0, right? You can see that our recall is about 100%. Means that our model is just accepting all the information, the negative, the positive, is just taking everything in and it's classifying everything as positives. But our precision is at 0, right? At 0.1. It means our model is just wrong. Accuracy also low. F1 score also low. So now we can see how threshold affects those different metrics. Now, if we go to the inference, we can see, and this is what I would like us to do after the class on our own, is we're going to copy this code, right? And this is just to make a prediction. We're going to copy this code and we're going to add our data set, our information of our table right here. And it will specify the model we want to use to make the prediction right there. And we'll make our prediction. I'm not going to do that for you, but I'm going to show you how you can do this. So this is model A, right? And this is where we are. So now that we have done model O, let's do model B. Now, I really hope we're following along because, yeah, this is really good skills to have. All right, so let's go and create a new model. But before that, let's look at our walkthrough and see what we're going to do next. So now that we've created model A, we're going to try to create model B. And to do that, we're going to have to create a new view of our data set. And basically, what creating a feature engineered view of your data set is basically you're creating new columns based on your already data set. You're going to do some aggregations and basically determine the combination of columns that could give your model more information to learn from. And I'll explain the code when we run it. So we're going to copy this code right from the create the view, and I'll explain it. So right from here. All right, and then let's use an SQL. Let's do it here then. All right. Okay. All right. So, okay. So now that we have our feature, we're gonna run through this code and see what we're trying to feature engineer, right? So like I said, now we're creating and replacing a view. The other time we created a model, now we're creating a view. A view is just a different version of our original data set. So we're going to go to our data set, and to copy the ID for your data set, really, all you need to do is just click on these three dots, copy ID, come here, paste it. So now we have our project location. And like I said, because of the dash in between, just try to enclose the project ID with apostrophe or yeah, or a quotation mark in a sense, but it's not really a quotation mark. It's just where the number one is. I'll find the name. All right, so we have our data set, and then we create a prediction view. So this is the name of the view we're creating, right? So let's just call it customer. We want to confuse each other. Customer train review, right? So this is the view we're trying to create in our data set. So we're going to go there and we're going to select the columns that we want from our data set. So we want our age, our estimated salary, and our purchase. So we don't need the ID, but we can add gender. So I'm going to do that again. So maybe that could influence it. So we have gender, ID, so age, salary, gender, and our purchase. So these are all the columns we have in our data set. Then we're going to make some feature engineering, which is where we're going to combine two different columns together to make a new one. And this is a basic one we're doing right now. We're going to combine the age column and the estimated salary, right? So we're going to see that the higher the age, is it going to mean higher salary in a sense, right? So that we're going to call that new column age salary interaction, right? So if we have created this column and we look through it, we'll be able to see that. You try to understand that if an older individual, are they making more money? Is the older the age, the older the salary, that type of thing. And then we'll also look at the ratio feature, the estimated salary per age. So we're going to look at your salary per your age, right? So basically all we're looking here is how age and the salaries interact. And then we'll also categorize our ages. So that's when you see case when age less than 30 and young, age between 30 and 50, and then or else, so anything after 50 and beyond is a senior, right? So then we end and then we call it. So what as means is we're calling that table age group, right? And then we're going to now specify from what original data set are we going to create this new view from. And our original data set is going to be from here. So let's copy the ID from this data set. We could just do this. Yeah, so the ID for our data set, copy this, and here, paste it here. All right, so we have, and again, close this. And we have a customer data set and then customer train data. Right? Customer train table. Right? Okay, and then select one sec. Okay, so that was in there. So this is not supposed to be here. Okay, so now we're going to create this view, and this view is going to be different from the original data set. So I'm going to show you what the original data set looks like and what this new one looks like. So when we click run, and it's running, it shouldn't take time. So let's go to the view. And again, you could either click on that button or you can just come right here and you see your view right here. So I want us to compare the two tables together. So I'm going to open new. So this is a table. So we have our original data set. This is the original table. If we preview it, we can see these are the original columns that we had. The original data set is on the right. So we can see we just have ID, gender, age, estimated salary, and purchased. Now, if you look at our new column, our new table, or our view, we have how many? So we have about 7 columns, right? And these are the new ones that we created. So I'll click on preview. So I'll just run this one. So let's run this. So this is our view. I just moved the view to the right, and then we'll open our original data set on the left. Hold on. Okay, so let's do this. Just do so. Okay, there we go. So this is our view, right? This should be our view. Yeah, so this is our view. This is a new table that we created. I just moved it to the right so we can see what it is. So we can see the new column as age, has our age group. So they're young. It has their salary per age. So this is calculations that we made, right? And then we still have our original columns, but now we just have more information from our model to learn from. And that's what feature engineering is. We're just creating more dynamic labels or columns so that our model can really learn what we're trying to teach it. So hold on, I want to show us this. So so now that we have our view, let's move forward and let's go on to creating our model, right? All right, so like I said, we created our view and we have that right here. So let's train our new model. And what does our walkthrough tell us is that our walkthrough says we're going to, after we create our view and we've seen that our view is created, we're going to train our model B. Now this is where things start getting interesting. We're going to have so we've done feature engineering. We're going to do some hyperparameter fine tuning, right? And this is what, and that's where I said we'll look at, okay. So this is what we're going to look at. So we're going to create a model, right? Model B, right? In our data set, we'll change this name and then the model type, which are parameters. So logistic regression, our inputs label column, which is our target column, right? Let me just put this here. Hashtag label slash target column, right? Big ball slash target hyperparameter tuning. No, it's not it. Okay, and then so then we now start to hyperparameter tune. So we're gonna, adjust the fire so our food cooks well, basically, right? So we're gonna do the number of trials. Number of trials, like the number of iterations that we want our model to learn from. So how many times do we want our model to run through that training process? So we're gonna do the number is 20. I'm gonna drop this to 10 because we don't have the time for that. Because the longer the trials are, the longer the training. You know what? I'll just make it 5. So the longer the trials, the longer our model trains for. And then we talked about the L1 regularization, which is our lasso, our least absolute shrinkage, which is supposed to just reduce our weights, the irrelevant weights. And then this is just a tag hyperparameter range between 0 and 10. So what this means is that we're going to look at numbers between 0 and 10 and see what what hyperparameters allowed our model to learn best. And so when our model is done training, we'll look at the metrics, the training metrics and evaluation metrics, and we'll see what it's saying, right? So we'll do the range is 0 to 10, and then the L2, which is our ridge, the hyperparameter range 0 to 5. So basically, this is just we're going to play around with the process is going to play around with these numbers with the combination of these numbers, right? And then determine the best combination that our model will learn from. That's what it is to hyperparameter tune. I'm going to put the level of the fire on 1, then switch it to 5, switch it to 2.5, switch it to 2.5 times 0.2, switch it to just different parameters. And then hopefully we'll determine which one our model learns from. And like I said, this is a lot more complex than it used to be back in the day. I wouldn't know, but I'm sure senior developers would really appreciate the way AI and technology has helped a lot of these things that we do today, right? So next we'll select, and then we'll select all from our project, our data set, and then the new view we created. So let's go ahead and create our model B. So we're going to copy this code and let's find this view. So just use the same SQL query, set tab, pick this up. Right. Okay, so we have, so let's create model B now. So again, create or replace model, our project location, and you could always just come and copy your ID from here, which is honestly the most efficient way. So you copy your ID and you paste it in just right here. Or you just, you know what, just change the data set to custom data set. Just on my data set. Oh, right. So now we have our project, our data set, and then where we want to place our model, our name of our model in this data set. So we have options, parameters, the model type, logistics, label, target column, our number of trials, our hyperparameter tuning. So there are a lot more hyperparameter values that we can use to mess around with our model, but we're keeping this as simple as possible. So we're just using these two. So some more complex models, we can even determine what the input and the output values are. And that's when we're looking at deep learning. But I'll leave that, and that's when you're developing a foundation model. So that's like the heavy lifting, machine learning and deep learning aspect of things. But we're going to keep things light and straightforward today so that we just understand the concept. So we're going to select all to select all columns. That's what asterisk means. Select all columns from our data set. So from our view, and the view we created was customer trained view. So let's just change that to trained view, right? So this is the view we created from our original data set. Oh, okay, and I need to change my data set too. So I'll just customer data set. See what I said about capital letters? It's very, very tricky. Just because of that, it wasn't going to run. See? Not found. They just said in this, not found. So just because of that. So pay attention to your naming, the nomenclature of all your files and models and everything is very important. So now you see this query run. So let's going to run this query and then we'll see what happens. Look here, no errors. So this is the time. So while the model is training, let's look at what we're going to do next. So like I said, because we're doing some hyperparameter tuning, it's going to take a little longer for the model to train and hopefully not too long because I reduced the number of trials. But once that is done, we should see model B created and we should see that here, right? So we'll see two models right here. So let's just wait for that to finish. So while that is loading, like I said, what we're going to do next is we're going to look at the metrics, the training and evaluation metrics for both models. We're going to compare those metrics. We're going to see who has the better loss, who has the better precision, who has the better accuracy. And then by doing that, we're able to determine if the extra effort that we put by hyperparameter tuning and feature engineering, if that is going to make this made model B more resourceful than model A, right? So that's what we're going to do. We're going to now answer who has the higher ROC, who has the lower log loss, and which model performs better. We'll also look at the coefficient matrix. We'll see who has the better rating on the coefficient matrix. And then we'll also look at understand the true positives and false negatives. But what you're going to do for me is and I think we'll talk about this in the next class, because I'm hoping that you did the assessments from the first couple of classes and they've been following along. But in the next class, we'll talk about the predictions and we'll see if there's a difference. And this is what I'd like you to do. And basically what you do is, since our model is still training, let's look at what it would mean to make a prediction. So if we went to model A, either by doing this, right, we can see that there is an inference tab. And that's what the walkthrough says. In the inference tab, it shows us the code to run the prediction. So all you really need to do is click open an SQL editor, right? And then fill in your table. So you're going to put in your trained data set. All right, you're going to put in your trained data set location, which is this one, or your table, sorry. So which is this one. Okay, so let's just put this as so, train table output. So this is what training. I'm going to make a prediction. So we're going to see if our model is going to accurately predict the values. But you should know that this is known data. If we're going to train it on, you know what? I will send another folder through, and that folder will contain a test. This, better yet, in the next class, we'll run after you do your predictions. We'll run the predictions as well in the next class. But I want us to do this personally for the next class, and then we'll do it again in our next class, and then before we move forward, and we'll see how our model performs and predictions. So basically, all you do is this: specify your table, your customer data set, all right, and then you run your prediction, and you should see predictions right here. So you see, this is our predicted values. This is our predicted values right here. This is what our model predicted. It predicted that this observation is false. And these are the prediction values. You can see false has a 0.9 and true is 0.0. This is the age. And then if we look at the actual, okay, I need to put the purchase column here. So let's add purchase right here so that we can compare what the actual purchase value is and what our model predicted that it would be. So let's run this again. Okay, so we see predicted purchase is false. This is what our model predicted. This is what our model valued our prediction. And this is what the actual value was. So our model was correct, right? So this is false. Can you even move it closer together so that we can see it? So let's just do this. So you see our purchase. So our model got this right. It's predicted false. Give this as value. It was correct. Another false, value correct. Let's see if it gets a true. Let's see any true. All right, so let's see. So we have a true here. This is the actual value, and our model got it wrong. Can you see? So it predicted that it was false. It predicted that it was false, but the actual value was true. So it means our model isn't as smart as we thought, and this is what it means to have to use more fine-tuning variables to get better predictions. So let's look at another one to see how our model did. So it failed again. So it's not getting the true positives, right? So one of like our metric said, our model A isn't the best version of this particular models that we're trying to build. So let's see if model B performs better. Let's check on our training. Let's see what's happening. Okay. Oh, it's gonna take a while. As you can see, if you look here, we can see that. So yeah, before I go there, this is what I want us to do. So we'll make predictions and look at our predictions for both models. And all you need to do really is just copy the code from from this inference tab in our model. So if you go to your customer data set, click on your models, click on the model A, and click on your inference tab, you see the code. So just copy it, run it, and then we'll talk about it more in the next class. So as you can see, our model is still training. It's been going for 6 minutes now. It would have been a lot longer if I said we should do it for 10. But the iterations I clicked max iterations at 5. I see, so we say trial 1, trained, evaluate, train, evaluate, train, evaluate, train, evaluate. And then after all these, the algorithm will pick the best version of our model, and that's what we'll use to make our predictions. All right. So the model is still training now. It's pretty much it. Lucky us. And just like that, our model is done. So if we refresh this, click on our customer data set, we can click on our models. We see we have 2 models now, model A, model B, both same types, but different training setups, right? So let's look at model B and we'll compare them together. So we'll look at model B and then we'll look at model A side by side and we'll see. And in order to do that, you just need to click here and say open in split tab. Right, so that's this one. And then we'll click on B, open in another split tab. All right, so now we have model A and model B side by side. Let's clean this up. So we see we have model A, model B side by side, and then we can look at the types, the same, basic information, the details. This should be different. So you can see that this doesn't have a hyperparameter. Model A on our left doesn't have any hyperparameter tuning job. Model B does. So you see that initially the initial training was 0, but due to our hyperparameter tunings, we have L1 regularization and L2 regularization, and we've modified the values, right? We've given it trials, which we set as 5, and maximal parallel trials is 1. So let's leave all that, but let's move on to our training metrics. So if you check training metrics for you, for B, B just has a table, right? So we just look at the trials 1 to 5. If you look at the loss, you can see our loss, that didn't even change. So our training loss didn't change, but I'm taking it because our iterations was 5. If we did it for longer, right, it would probably have affected the loss a lot better. But as you can see, the loss is still, right, still the same pretty much. So that's not good. Well, like I said, we're just looking. All right, so let's look at the evaluation. Now we have our list of trials 1 to 5 and our table. So we have the aggregate metrics. And if we look at our threshold is the same as 0.5. If we look at the precision is at 0.5. Our precision is 0.7 here, so it's higher. So it means our model is able to identify more true positives just because of the fine tuning that we did. We look at our recall is at 0.5. Recall is higher here too, higher than this. Our recall here was at 20%, so that was very low. At 50%, that's better. We're making progress with our learning job. And accuracy is 0.8 but 0.9 here, so it's higher in model B. F1 score 2 obviously will be higher because our precision and accuracy is higher. And our log loss fortunately stayed the same throughout all the iterations. And this was the lowest log loss for this training session. But as you can see that our precision and recall accuracy have all gone higher, although the threshold was the same. Because of the hyperparameter tunings that we did and the feature engineering, our model has learned more and is able to make more accurate predictions, right? So, and then we look at the ROC curves, and that increased as well, even if it's just by 0.3. So that's increased as well. So that's good. So we've made progress, right? Our training job has made progress. Let's look at the graph. As you can see, our position is just going high, right? This one here, it drops. Let me try and make this bolder, right? Our position here drops, right? But here it goes higher. While the recall, but this is our sweet point, right? This is a point at which, let's look at the sweet points and track that. So the threshold here at 0.4, we had a precision of 70% and a recall of 73, which is actually very high and good. While we had here for that sweet point, we had 59 and 61. So you can see there's progress. Our model has made progress, right? And then in the precision recall curve to indicate our performance, our precision is closer, it's a lot closer, right, to 100% than it is with this one. The precision here is low, right? But this is closer to 100%, and it just gradually goes down because the higher the recall, I think that affects vice versa affects precision, right? Unless you're trained the model as much as possible where you have very good precision and recall. That's basically what you're looking for, like good precision, good recall, right? And then the area under the graph is 0.7, which is good. So that's high and that's good. The area under the graph here is 0.9, 0.96, which is also very good. As you can see here, there's a difference. It's going up, this is exactly what we want. If we look at the confusion metrics, right? We're having good values here. So we're getting 100% true, predicted true. This is wrong, and I'm thinking this is wrong as well because when we looked at our predictions, well, then again, in next class we'll look at it better and we'll see what really went wrong. So now what we've done now is we have evaluated two different models, right? We've looked at A and B, and we've seen how the fine-tuning and hyperparameters fine-tuning and feature engineering have made this model work a whole lot better than model A did, right? In terms of precision and accuracy, model B is winning in my terms, right? And I hope that I'm able to illustrate that point. So with that said, I think we've come to the end of this class, right? And I would have really liked it if we could make it as interactive as possible, where we were, trying to run the code together and getting it together and getting our models up. But I'm hoping that you can run the walkthrough personally and do the predictions. And then in our next class, we can talk about this before we move into the topic of the day. So I will stop sharing my class. I would like to ask, is there any questions? Is there anything you want me to quickly go over? I know I ran through this, but I tried to keep it as direct as possible throughout. So is there any questions? Are we good? Are we ready to go and work on this, build our own models personally? Is there anything we would like to touch on before we call it close for today? Anything? Are we all good? Is that what we're saying? All right then. Well, that being said, I will leave it to our host to effectively close the class. Thank you all for your time. Thank you, Patricia. Thank you for coming. I'm glad we made it this far. And I hope that we can continue to move forward with this course and you continue to learn. All right. So thank you all. Thank you for having me. I will see you next time.
Thank you so much, Melvin. Sorry, Mufta. Thank you so much for the session. It was really insightful. Let's appreciate Melvin in the chat box, please. Let's all appreciate Melvin. Saying Melvin. Thank you so much, Mufta. Please don't forget to fill in your attendance form and the feedback form in the chat box. And also, the material used today will be sent to the chat room and the recording of the session. So thank you so much, everybody, for joining us. We'll be catching up again Same time next week Friday. Thank you.